Hey, seventh grade. I won't be in today. I'm hoping that I will be back tomorrow. So bear with me today. We're gonna do an e-learning video. Make sure that the notes that I take, you take down too. Don't just stop the video and copy what I have. Listen to it so that you understand. And when we go to Tuesday's lesson when I get back, you know what's going on and you haven't just copied down the problems, okay? So I really expect you guys to listen, and if you have questions, come with your questions on Tuesday and I can answer them, okay? All right, so this is page S18 in your books, at the front of your books. It's lesson 3. Make sure you have the right version of your book, modules 3 and 4. Okay, so example 3 on page S18 says, find an equivalent expression by modeling within a rectangular array. We're not going to model using a rectangular array. You can cross that out. And applying the distributed property to the expression. So we are going to use distributed property. I know that Miss Marzullo actually talked to some of you guys when we worked on this when I was last there. She called it kind of like circle rainbow. So I'll show you what that looks like. So I've just copied the expression from above. We need to use distributed property. So whatever is outside of the parentheses, we need to distribute to what's inside. So if it helps you to know what's being distributed, make sure that the 5 gets distributed to the 8x, and then the 5 gets distributed to the 3. Right? So everything inside of parentheses will be multiplied because there is multiplication between this parentheses and that number. Everything that's going to get inside parentheses gets multiplied by whatever's outside. So then it's just a matter of doing it one chunk at a time. 8x times 5. So 5 times 8 is 40, and then just add the x to the end. So we have 40x. And then we have a plus symbol here. Let me make this x look more like an x. Okay, plus. So then 5 times 5 times 3 would be 15. So I'm going to add 15. So that's pretty much it. This is an equivalent expression to what it originally was. We've just applied the distributed property. So that's it for example 3. Let's move on to example 2, exercise 2. So this one's a little bit different. It's similar but slightly different. So same page, exercise 2. For parts A and B, draw the array. We're not going to draw an array, but we are going to apply the distributed property to expand each expression. Substitute the given numerical values in to demonstrate equivalency. So first, we're going to use distributed property. Then we're going to substitute in values, or plug and chug is what I like to call it. So let me see if I can move this a little bit more. Get my hand underneath. Okay. So this is what we're going to do second, substitute. So we're going to use distributed property first. So we have 2x plus 1. Whatever's outside of parentheses needs to get distributed inside of parentheses. So that's one term. And then here's the other term. So 2 times x is 2x plus symbol. Okay, and then 2 times 1 is 2. Okay. So this is our equivalent expression right here. So that's step number 1. We use the distributed property. Okay. Step number 2 is to substitute. X equals 5. So they told us x is equal to 5, so we have to plug in a 5 wherever we see an x in our new expression. So it's going to look like this. If we have 2x plus 2, this is no longer going to be x. We're going to replace it. We're going to substitute it in, just like I'm not there today and there's a substitute there. We're going to replace it with a 5. Those are going to be multiplied together because here they're being multiplied together, and then add the 2. So then you just have to solve this. 2 times 5 is 10, and then 10 plus 2 is equal to 12. So they basically want us to show that using this expression that we got from the distributed property, we would get the same answer as if we use the original. So I'm going to split down my page, and the original expression was 2x plus 1. This is the original. So if I plug in a 5 into here, because that's what x was, it would look like this. 5 plus 1. So now order of operations says do whatever is in parentheses first. So that would be 5 plus 1 is 6. And then 2 times 6 equals 12. We get the same answer using the expression that we got after we used distributed property as the original. So 12 is equal to 12. They are equivalent. Okay, so as you can see, there are steps to solving this problem because this question had 2 questions in one using distributed property, which is why we did this. And then to check for equivalency, that's why we did this part, okay? So here's another example for you. I'm going to start it. You're going to finish it, okay? So same steps, use distributed property first. So we have, the camera focus a little bit, okay? We have 10 2c plus 5. We're going to take this and distribute it to the 2c, and then take the 10 and distribute it to the 5. So you might be asking yourself, how do I know what to give it to? If there's an operation, like addition, this is a term. So you're going to make sure that you distribute it. You give it to each term in the expression. So one step at a time again. So 10 times 2c would be 20c plus 10 times 5 is 50. Okay, so here's our new expression. Okay, now we need to substitute in. So this part right here is telling us plug 1 in for c. So c is equal to 1. So now I'm going to take my expression and let me separate the old work. Okay, I'm going to try to stay in this area. Okay, so I'm going to plug in c for 1. So I'm going to substitute c equals 1. So 20, instead of c is 1. So I'm going to plug in a 1 plus 50. So this means 20 times 1 plus 50. Well, 20 times 1 is 20. Plus 50 equals 70. Okay, so now I need to show equivalency. So if I had used the original equation, I need to show that this is the same, that it would be 70. So 20 or 10 parentheses 2, instead of c, I'm going to write the number 1 plus 5. We do what's in parentheses first. So 2 times 1 is 2, plus 5 more is 7. Okay, see? Now you're going to finish this part, okay? 10 times 7. Just verify that these are equivalent, and then let's move on to the next question.